Hello, in this video I'm going to show you how to use the clustering tool in MATLAB. So we're here on the main screen in MATLAB. We go to apps and we have our neural network clustering, so self-organizing map. We can click on it, or you can type in nctool for neural clustering tool if you don't have this modern version of MATLAB. Okay, so we're going to go next. We're going to use one of the example data sets, the traditional flower set, and make sure that you always check your inputs. So we have 150 samples and each sample is made out of 4 measurements. Okay, so careful, we did it the other way around. We only have 4 samples and each of the samples has 150 components. In our case we're working per columns. We create our network, so we leave it, then click train. It gets trained, and here we can have a look at the results. So these are all our clusters, our nodes on the network, and there's 4 elements in this neuron, 2 elements here, 1 element here, and so on. Okay, and there's some empty spaces as well. Okay, we can also look at the neighbor distances. Lighter colors mean the 2 neurons are very close. Darker colors means there's a big difference between the values. Okay, so we keep going. We're now going to have a look. We could refine the performance. In our case, we're just going to go to the end, and we're going to look at how do we know what elements of the inputs, what inputs are in which of the neurons. Okay, so we don't need the network. In this case, we're just going to save the outputs. So I'm going to call it outputs iris and finish. We could generate a script, and that means that then later on we just need to run the script instead of go through the menus. In this case, I just want to show you our values. So we have output iris here. If we open them up, you can see here we have 100 by 150. So we have 150 columns. They are each of the flowers that we're analyzing, and for each of them there is 100 rows. Each of those rows represents 1 neuron, and you see how most of the values are 0. Each column will just have 1 value that is not equal to 0, that is equal to 1. So we go for element 1 and we keep going here. So the first flower that we entered into the system, into our self-organizing map, got clustered in neuron 40. If we look at the second one, similar idea. We start from the beginning, everything is 0, 0, 0, 0, and this one is clustered in neuron 79, and so on. Okay, so this is how you get your outputs. You could look across and see, okay, the second flower and the 30th flower are similar, they're in the same cluster. Okay, this is solved. Bye.